Hey folks! So we're done with chapter 2, at least the content. So these videos are kind of like a class. If I'm teaching a class on this book, I've said everything that I would generally say for a class. But I would also tell my students that, in this book, it's a big book. I have a lot of stuff in here that I would advise a student to look at on their own. So for example, I suggest students read math and study, examples that were not covered in class. So to help support that for, Intro to Proofs book, I actually have a section at the end of each chapter. So this is chapter 2's section 2.6 on bonus examples. And you can tell, let's see here. So proposition 1, assume x and y are positive integers. If x is bigger than or equal to y, then the square root of x is bigger than or equal to the square root of y. So, it's kind of like these problems we've been doing before, but the algebra is a little trickier, right? So you have to, it's a challenge problem that, you can do most of the introductory work, kind of squeezing towards the middle of the proof, but the middle part is a little bit more challenging. And after that, there's a theorem, a famous theorem called the AM-GM inequality. It stands for arithmetic mean, geometric mean. So we go ahead and prove that, which is a nice result and a good one to know. And then after that, I have this section called Pro Tips. Chapter 2, Pro Tips. This is kind of a fun way to introduce you as students of math, right? You're learning proofs, but you're also students learning math. And so these are little tips for you, suggestions. First one, let's see. When reading a definition, get into the habit of asking, why is it called that? Often the word that mathematicians choose provides some intuition for what's being defined or suggests a connection to something else. All right, so I talk about that for a little bit. Number 2, definitions not only offer us precision in our language, but they present with us objects worthy of study. It has always been the case that 6 and 28 were the sum of their proper divisors. But when such a property was given a name, that of a perfect number, then it became a concrete, tangible thing. It allowed mathematicians to focus their attention and sharpen their dialogue. So, it goes on to discuss this. It's something worth thinking about. Next 3, talking about the value of certain topics. Modular arithmetic being the notable example in this pro tip. Number 4, talking about some subtle stuff about proofs by cases. Then mathematical notation, something Penny and I feel strongly about. Anyways, so it goes on. Some more stuff about primes, some stuff about continuing the analogy at the start of the book about proofs are like a computer program in some ways, but not others. Talk about the Feynman technique in the last one. Anyways, so yeah, if you find these things valuable, feel free to check them out. And then I have a bunch of exercises that just run the gamut on things that we discussed. So I strongly recommend you work on some examples. Let's see, they go from everything from more practice with the beginning stuff, proving that, things about even odd numbers, stuff with absolute values, quotients and remainders, Pythagorean theorem, some mod stuff, some special stuff about divisibility, least common multiples I introduce, and then ask questions about counterexamples and give you some counterexamples, ask you to find some things for which there exists a counterexample, and you the conjecture is wrong and you have to find the counterexample to it. Anyways, so some stuff. And then I have an open question. Remember, at the end of every chapter, I have an open question. A little bit of a glare. But the open question, it's a question which no one knows the answer to. So what is this one about? Oh yeah, perfect numbers. Yeah, so I discussed perfect numbers, and so a page building up to it, and then the thing at the end. Interesting problem, and kind of relates to what we've been talking about in subtle ways. So okay, so that's that. And then at the end, after the chapter is done, after every chapter, because this is an introduction not only to proofs and to being a mathematician, but just sort of higher math more generally. So I have an introduction to number theory after this chapter. So after every chapter, I have an introduction to some advanced area of math. This one, it's number theory. So I look at primes, prime number theorem, cryptography, RSA algorithm, finding the lock and key for it. That rates the Fermat's little theorem. I show why it works with Euler's theorem, the totient function, talking about very big primes. So yeah, it's, I don't know, what was that, 8 pages or something? And 8 or 9, I think. And that's the stuff at the end. So I would tell you the same thing I would tell my students. I recommend you read through these if you have a copy of the book and take time thinking about them. I mean, I spent a lot of time on these because I think it's valuable stuff. So go ahead and give those a look. And if you do this every chapter, you'll digest 100 pro tips and 9 8-page introductions to areas of higher math, and then you'll feel round out your intro to proofs in higher math education. Okay, so that's it. Come back next time when we will start chapter 3 on sets. See you then.